telling you, you need to use concrete. In this class, the easiest way to disprove things is using a concrete example. Compare the board that he just worked on over there, the right side, versus the left side. Now, if you're taking the test, which one do you want to be doing? And not only that, the one on the left, he needs his backwards arrows in there to show that, in fact, he's starting with a true thing. Right, so those are necessary. But all you need to do when you're showing that a statement is false, and you should be overjoyed to find something that you're disproving on the test. Because usually in here, when you get into a topology class or something, finding counterexamples can be really, really hard, okay? But in this class, they'll generally be pretty straightforward. And that's what you want to do. You don't want to be writing out a disproof of, a proof of the negation of the statement, right? Because that even can be difficult, right? All you need to do is find one single example to show that it's not true. So does everybody understand why this is a correct solution on the right board? He's picked up an A, he's picked up a B. Concrete ones. In this case, he said A equals 0, B equals 0. He checks that the hypothesis is true. Okay, 0 is less than 0 plus epsilon for every epsilon bigger than 0. And then he checks that the conclusion is false. It's not true that 0 is less than 0. He's done. Okay, the only thing I might, just if you wanted to clarify it in your own mind, you could say that, for example. But this is all you need to do. And when you're taking the test, resist the temptation to try to actually disprove. Doesn't mean to prove the negation. Disprove means to find a counterexample. It's much easier. Okay, questions for Austin about this? You're going to want every minute you can get on the test, okay? So dive in straight to the counterexample if you believe the statement is false. Okay, thank you, Austin. Okay, so that brings us to 218. There are two parts of that also. Half the time I feel like apologizing for 218, because, especially the first part, because it just involves a lot of cases, and it isn't very interesting. But on the other hand, splitting things up into cases is something that happens in a lot of proofs, and you need to get used to doing it. And usually it's just a matter of bookkeeping, and then being careful that you get every single case, and then you have to prove each of those cases. Okay, so let's see. This is 18. This person didn't claim. Let's see. Okay, James Tucker. That's you're doing 18.1. And Michael Schutz. James Tucker. It's funny how the same people keep doing it, but that's why we have the James Tucker and Michael Schutz. Well, Michael's up there for the first time, so. Yeah, several people didn't, and James will just handle that. Like I said, if you try in the future, because there's a chance that he'll miscount, because we got like all kinds of different things there, and the easiest, if he miscounts, it's going to be an undercounting, right? So no, don't fix it. He can handle it. I'm just saying that it's easier for everybody concerned, except maybe for you. Right, because you have to write down an extra step. But anyway. Okay, James, what I'd really like you to do here, oh, okay, never mind. I was going to, what I really like you to, I didn't realize you were about to do your cases. Okay, good. Okay, fine. I was going to say enumerate them and work on them, but good. So Michael, I think I'd like you also just, so how many total cases do you have?
Right. I broke it down, because I think I'm doing these two, and I'm doing the whole.
Well, you've got an OR statement there, so really, I mean, if you can break it down, I think it'll be simpler for everybody, and it's good practice for you guys. There are really two cases, right? So 0 less than x is always there, and then you have that plus x equal y, and then the second case is that plus x less than y. So why don't you just start with case 1, and let's just go from there. Okay.
No.
Okay, James, you put that last thing up there, which is fine, except the arrow should go the other way. Or it'd be a double arrow.
Okay.
Your little arrow.
To show that this is all we needed to prove for each of these cases.
But since your conclusion is to the left, your arrow that you have there,
Here?
yes, that should either be a double arrow or it should be pointing to the left.
Okay.
Because the thing on the left is what you're ultimately after, right? It is a double arrow, right? But if you're going to have a single arrow, it definitely needs to go that way. Okay, so that's your,
Kind of long.
okay, that's your less than case, but there's still the equals case, which is actually pretty straightforward, but anyway, it is there. The case when x equal y. Yeah, go ahead and, I think everybody's got the office hours right? Did he do the x, you didn't do the equals case, did you?
No,
No, I didn't, okay, right. And everybody can, have a look at what James has done already. Just for those of you who are thinking about what James did there, you should be thinking about his double arrow up there at the upper right and what that means exactly and why that's something that one should do. And just continue with that. Just continue with an equals. I mean, no, literally, just put an equals to the right, and then
Yeah.
what is that equal to?
That's, I'm just substituting the y.
Yeah, cy.
Y is here.
Or either way. Yep. Okay, that's it. Okay, so you don't get free yet. Okay, because there may be questions. And okay, so let's start with James. Explain what you've done and why there are 4 cases. If you did this, you should have had 4 cases one way or another, even though 2 are similar. Okay, go ahead.
So we have 2 or statements right here in our assumption. So as I wrote out here, x is less than y or x equals y, and the same thing for z and w. So we have 4 cases here. I just went through each case. Since we have an and here, we have to assume 2 of them. So I assumed 2 for each case, and I just made sure I went around and got all of the cases in there, so there are 4 cases. And then with each one, all we have to do is prove, like you showed here, either x plus c is less than y plus w, or they're equal.
Right, that's an important point, right? When your conclusion is an or, and we saw this even in some of the first set theory things that we did. When your conclusion is an or, you're done if you hit either of them, right? You don't have to check both of them. And so it's good that he put that up there so that now you can come down and look, and for each case he's hit one of those or the other, right? And so that's a great strategy for doing this, right? And not repeating it every stage. Since we have an or statement, I mean, you could add that, but again, the goal here is to be lazy but correct and clear, right? Okay, so that's a good way to do it, to point out in the advance that all you have to do is hit one of those 2. Okay, so start with case 1.
So then case 1, let x is less than y and z is less than w, so then by the additive property, is it? You can add to both sides. I get these 2 statements, and then by transitivity, I can say that x plus c is less than y plus w, which is one of our statements that we're looking for. So in case 2, here z is equal to w. So instead of transitivity, I just substituted a w for a z, which gets us the same thing. Then case 3, similar to case 2, except they're just swapped, so x equals y and z is less than w.
Yeah, so that's a definite similar, right? When all you have to do is change the letters, there's no question that that's a similar proof.
And then case 4, for x equals y and z equals w. So we just have the added z on both sides here, and then substituted w for z again, and they're equal, which is still one of the things we're trying to prove. And that gets all 4 cases.
Okay? Any questions about this one? Now, I was just going to look at one thing in here. because I have some recollection that we have in 214. What do we have in problem 214?
Well, virtually the same thing.
Well, when you say virtually, you're meaning that just the letters have changed. The names of the players have been changed to protect the innocent or something, okay? Right, so I was fine having you do that because we actually skipped 214, but what you did in case 1 is actually 2.14.
Okay.
And so, again, from the standpoint of being lazy about it, you could have referred to 214. But like I said, I'm glad you did it because we didn't do that one, so now everybody sees how that works.
Okay. So yeah, in that case, we would just skip this line and have.
You would just say, yeah, you would just say that this is